phone on my phone, then you're going to observe W1 as how we're going to observe, it's a bag of words, is you're going to observe W1 equals how, W2 equals can, W3 equals I, W4 equals call. Oh, phone, sorry. How can phone? Okay, that makes sense? So we're going to build a simple model where each of the words independent of each other. Of course, it's not a very good language model, but what we do is then we can do a bigram model. So there's another probabilistic model. You know what this says. You need the probability of word and the probability of word given the previous word. Right? So just by drawing this diagram, now we know enough to just be able to interpret this. So you need the probability of W1, the probability of W2 given W1, W3 given W2, etc. So it's a range of the variables, a set of all words. The probabilities are provided is the distribution over words for each position given the previous word. And now we're going to condition on the same sentence. It's exactly the same thing we did before. So now we're going to, how can I phone my phone, is going to be a bag of words or a bigram model, has got the same thing. Does that make sense? All right. So hopefully you can understand it. And there's also trigrams where the two previous ones. So there's a trigram model. So each trigram you're looking at triples of words. The probabilities are each one. And in general, the probability of each word given the previous two ones. And now we have an n-gram as the probability of each word given the previous n-1 words. And so what we can do is we can start using these models to predict what we're going to do. So here's how we're going to work out. Here's how your phone, it's a model like this that your phone uses for predicting the next, when you start typing in an email, a message in your phone and it starts predicting words, is the model like this that it uses. It is each word given the previous words. And there's this interesting, Google sort of publishes, some are called n-gram viewer, which they publish all of the n-grams up to 5 grams for all the books that have been published that they have digitized over the last few hundred years up to 2008 or something. So you can actually do this. So let's go to, I've got to do this. Let's do this. So here's their model of so what they're doing here is they're plotting, so this is, would you go to their page, you have Frankenstein, how many times Frankenstein is used in a book since 1800 to 2000, Albert Einstein and Sherlock Holmes, and how often they appear in books. Okay, so let's use it for, actually I think it goes to 2008, let's do that. And you can do things like logic star. I'll do this one. So you can predict, let's just do Bayesian star. So you can predict here all the words Bayesian followed by something up to 2008. And the top one currently is Bayesian network. So if you see the word Bayesian, you'll probably see network in there. If you see Bayesian approach, Bayesian inference, Bayesian analysis, you can predict what the next word is. And if you type Bayesian network, the following word for that, if you see that, you're going to find out Bayesian network is. Okay? And you can do, and we can do, let's go. And we'll do Bayesian and logic. And the first one's a logic of and logic and logic programming and logic is and logic in, and Bayesian network is above, is not as likely as logic is of and logic and. right? Logic programmers in there. So logic is a lot more popular than Bayesian. We can do other weird things. You can say, what's the most common word? And it'll tell you the most common word is the. And so then you can type in the, and you can find out what the next word is. So it's the followed by the same, right? And now we can do predictive words here. The same. I've already done this before you. That's why it's filling in for me. The same time. It's so much more popular, isn't it? Right. The same time. Yeah, there's the same time as the, I think it gets, time. I can do this one. It actually rejects this one, I think. It doesn't like it. It only lets you do 5 grams. So it only lets you do 5 in a row. Okay, but it tells you essentially the probability distribution over all of these words. Okay, let's, so you can play with it. It's fun to play with. Where am I? All right, so now let's tell you. So now, because we know what Bayes nets are doing, here's how your spelling corrector works on your phone. Right, you have a probability of each word given each previous word, so it predicts the next word. For each word, you have a prediction of the letters that are in that word. So this gives you an error. So you want the word, but you type in the letters, and then but it has error correcting. So sometimes the letter, it's more likely that it's a word even though it's wrong. So you can still be wrong. You can still type wrong things even though it starts. So once you start typing in letters, it gets the most likely words. Given the previous word, I think it only uses the previous word, and the previous letters. So here's how you do predictive typing with the things we've seen before. And we do 2 more. Any questions about that? Because we didn't have this nice thing, we can just draw diagrams and say, here's how it works, right? It's such a nice thing. I won't do that. Here's another one to do is, this is called so-called topic model. You can type talking about, so all these words at the bottom, the topics up top. And now we have the probability of nut, given that it's a tool and a food. The probability of salmon is very unlikely if the topic is tools, but it's more likely if a topic is fish or food. So we have all this probability of each word given every topic. And here they assume the topics are independent of each other. The words are independent given the topic. But the words are dependent because you have similar topics. So here's a topic model for building this. And so here's the thing. And so what happens is that 2 years ago, Google search got way better. And I'm told this is the reason why. It now uses a topic model that it learns from data. It has this word model, and it has 12 million words. And if you think and scratch your head, you find that's too many words. But every little phrase is a word. Every common phrase is a word. And when you type something in, it tries to work out what topics you're talking about, so that it can then predict other words. So now it's all of a sudden changed so that you need to see the words in this model before we did this. But Bayes nets, you can just draw this diagram, you sort of sudden, that's what it is, right? So it's just what we've seen before. So, of course, their challenge was that they have to answer questions in 0.1 of a second or something with a model with 350 million links and all sorts of things. And they learn it continuously. So it's continually being learned, this model, and they update things quickly. All right. All right. So let's stop there. Hopefully that was sort of interesting because it's just things you've seen before. It's just the things we taught in the course are actually used. All right, so here's the overview again we're doing. And we'll have a review session sometime. Keep track of Piazza. All right, thank you.